Well, hello class. Welcome back. Happy Monday. We are at it again. Hope you had a good weekend. I just wanted to show you real quick here. I think this white space, I'm going to try it in. What I've been trying to work on this weekend. About a week ago, my dryer quit working. And so I know I was looking it up. I thought I had to change the thermal fuse. It's not that I know a lot about these things, but Google is pretty good about teaching you stuff. And I've watched a lot of videos, and so I've learned some things about appliances. But this is what I found. The dryer stopped drying, and this end should look like this end. The little clip, the disconnect, the fast disconnect burn off. So I found it. I know why the dryer's not working. No need to worry. It wasn't an issue of my house burning down or anything like that. I found out that any of you who know anything about electricity, if these aren't tight enough and this crimp isn't tight enough, it creates too much resistance, which creates heat, and then just the wire melts. It has nothing to do with the heating element that this attaches into. So it looks big and scary. I don't know if you can see that. This is all melted here, but the heat's generated right at the wire, not at the heating element. So that's why it melted off. So I just have to recrimp it, make sure it's all tight. Maybe I'll solder it, and it should be good. So that's what I'm working on this weekend. As we go into Monday here. So I just wanted to let you know that I'm doing all kinds of stuff. I'm not just making videos, or maybe it's the case when you were little. You remember ever seeing your elementary teacher like in the store, and you were all amazed that she actually has a life outside of school. She doesn't like live at school. I just wanted to tell you too, even though I'm actually living at home, right? I can't leave my house. I still am doing other things. So just wanted to show you that, something that I'm doing and working on. So anyway, let's get back to work, right? One of my rabbit trails. We are in chapter 12, and we are now on annuities in chapter 12. And we ended last week by doing the present values. And so we used the tables. We use the present value of an ordinary annuity. Just as a quick refresher, ordinary annuity, the payment is made at the end of the compounding term, all right? And we use tables to figure that out. And here's my new pointer this week. Hope you guys like that. It's Groot, all right? And the present value, all right, of an annuity due. And an annuity due is the payment is made at the end of I say that backwards every time. The ordinary annuity, payment made at the end. Annuity due, payment made at the beginning of the compounding term. All right? And as we use the tables, we have to beware. Each time we do figure out what N is, the nominal, how many conversion periods there are. And that's years times the periods, compounding periods in a year, and then the little I, and that's the nominal interest rate divided by the number of periods in a year. So we're finding the interest rate per compounding period, all right? And so we just go to the present value table for annuities, and we go across the top with the interest rate per period and the number of compounding rates. You guys are familiar with that, all right? And that's for the ordinary annuity. Now for the annuity due, we have to do it a little different, all right? So we calculate the number of periods, and then we subtract one for the present value. For future value, we added one. For present value, we subtract one from the number of periods, total compounding periods. All right, we find I, so then we go to our table. And in the table, remember, this is an ordinary annuity, all right? This is the present value for the ordinary annuity, these factors. So you find the factor, and then we have to add one. For the future value, we subtracted one. For the present value, we add one. Okay? So those are the differences. And then once we add one to that factor, we multiply it by the payment, and that's how we find the present value. Okay? So we did that. Now, instead of using tables, all right, we can use a formula. All right, and just like we did for future value, we have a formula for present value. Okay? And so in this case, as I was saying before, we still have to find I, we still have to find N, and I like, when I use the formula, to write down what 1 plus I is. It's just easier to plug into my calculator. Noticed in this formula, all right, this is the ordinary annuity formula for the present value. So the present value equals the payment and the payment is made at the end of the compounding period because it's ordinary. So the payment times 1 minus, so it's flipped this time, not this 1 plus I raised minus 1. It is 1 minus the quantity 1 plus I, and notice it's a negative exponent. So it's 1 plus I raised to the nth power, negative nth power. So when you plug it in your calculator, when you go to put in the exponent, you have to put a negative number in for the exponent. Okay? And for those of you who remember your algebra, a negative exponent means that you are taking instead of this being in the numerator, you're making it's 1 over this amount raised to the n power. Okay? So whenever you have a negative exponent, you're just flipping it from the numerator to the denominator, or the denominator to the numerator. Okay? But just plug it into your calculator as a negative exponent. So 1 minus the quantity 1 plus I raised to the negative n, all over I. All right? And then the annuity due formula, when the payment is made at the beginning of the compounding period, it's the payment. Basically, it's the same as the ordinary. Payment times 1 minus the quantity 1 plus I raised to the negative n, all divided by I. But then you're going to multiply all of that times 1 plus I. All right, so that's important. Once you find the ordinary annuity using the formula, you can easily find the annuity due, because this part is exactly the same as the ordinary annuity, by just multiplying it by 1 plus I. So let's look at that. All right, so again, we are trying to figure out what is the lump sum we need now, so that if we make payments out of that lump sum by the end of the annuity, we should have 0 left and we made all our payments. All right, for a particular future value. So PV is the present value, the payment, I is the interest rate per period, N is the number of periods. It talks about how to punch it in your calculator. And I would suggest writing down what 1 plus I is. All right. If you have a calculator that you can put this in as a program line, an algebraic line, that's great. But again, we need to know what this is raised to the minus nth power. So if you can save that in your calculator, that's great. All right. If not, you have to write it down, and write down as many digits as you can. All right. So the more digits you write, the more accurate your answer is. All right, so once you find 1 plus I raised to the negative n, then you're going to take 1 and subtract that. All right, what you just found. And then once you have that, you'll divide by I. All right, so as we walk down through here, it says, what is the present value of an ordinary annuity of $100 per month for 4 years at 6% interest compounded monthly? And then what is the present value of the investment if it is an annuity due? Okay, so we need to find what I is, and we need to find what N is. So I, it's 4 years monthly. All right, so if it's compounded monthly, this 6% is going to have to be divided by 12. So that's going to be 0.5% per period. We're also going to see it's 4 years. N is 4 years times 12. So that's 48. For the present value of an ordinary annuity problem, we use I equals 0.5%. That's what we just talked about. The 6% divided by 12, compounded monthly. And N equals 48, 4 years times 12. So, and again, what I like to do, I like to write down what 1 plus I is. I just like to have that. That way I can just punch it in if I need to. So they're using their calculator. They fill it in. I is 0.005 raised to the negative 48th. Well, 1 plus 0.005 is 1.005. Then they raise it to the negative 48th power. That is 0.787098411. So then it's 1 minus that. So that gives you 0.229015889. Now this is all divided by I. So that gives us 0.00 over 0.005. So that 0.21290 blah divided by 0.005 equals 42.58. Multiplying that by our payment, we should get $4,258.03. All right? Great. Okay. Now, as you go through this, remember that when they ask you to find the annuity due. So this is the ordinary annuity. This is the lump sum we have to put away now so that we can make $100 payments a month for 4 years. So that's $4,800 that we want to pay out. So we're getting just short of $600, $542, all right, of interest in doing it that way. To find the ordinary, or that was the ordinary annuity. To find the annuity due, we can take the ordinary annuity amount, and now we're just going to multiply that by 1 plus I, because the formulas are the same, right? So $4,258.03 times 1 plus 0.005. That's why I like to have that ahead of time. Multiply those together. We should get $4,279.32. So if we make payments at the beginning of the term, we have to have a little more money up front. All right? Because we're earning less interest, if you think about it, because we're making payments earlier. All right, so they give you the calculator sequence there. So what I'd like you to do, let's practice. Let's try. Let's do the try it exercise, please. So use the present value of an annuity formula to solve the following. Angus wants $500 at the end of each 3-month period, quarterly, for the next 6 years. If Angus's bank is paying 8% compounded quarterly, so it's simple, how much must the deposit be now to get the desired ordinary annuity? All right. So again, he wants $500 at the end of each 3 months. He wants that. So how much must he put away now, compounded quarterly at 8%, so that he can do that for the next 6 years? All right. If Angus wants the payments at the beginning of each 3 months, now it's an annuity due, how much should he deposit? All right. So go ahead, take a moment to figure that out, and I'll come back with the answer.